Because we had okay, yeah. So it is now plugging in the ID, which is nice. So of course, I'm using the community edition of IntelliJ because I'm too cheap to buy the enterprise edition for my personal laptop. So we'll go without plugins for right now. So I'll dive in a little bit about what OpenRewrite is all about. So OpenRewrite at its core is an open source semantic search and transformation framework. And what that means is a fancy word for basically it takes source code and converts it into what are called LSTs. So you traditionally you'll hear ASTs. These are what compilers, they take source code, they convert it to an abstract syntax tree, and that's what they use to like then convert it to machine code. Well, an LST is a little bit different, kind of the same concept, except that it has two extra pieces of information. It keeps track of all of the white space, all of the comments, all the formatting, right? A compiler doesn't care about that, it throws it out. If you're going to take this, convert it to a tree, make transformations and spit back out the source, you obviously need to keep track of all of that formatting. It's very important. So OpenRewrite is, I think, if you see most of the talks, if you do any searches out there, I would say like probably 90% of them are going to be like, this is going to do a framework migration, right? Like take Spring Boot from 2.x to 3.x, or take Quarkus, blah, like it goes on and on and on. You're going to see a lot of that. And we're going to actually start out with that because, it helps kind of frame the type of things that this framework can do. I'm going to try to transition and try to like cover some new territory here where we're actually going to go into what's going on underneath the covers. Like what is a recipe? What is the visitor doing? Like a visitor pattern as it visits these LSTs. How the hell does the framework convert source code into these trees, that sort of thing. So we're going to do kind of a deep dive. We'll go through some of the testing also, like there's a test harness. So we're going to create a couple of our own recipes and just kind of show off some of the capabilities. It's more than a code transformation. I don't think people realize that it's actually really good at doing searches, right? If you have semantic awareness of everything, you can do some really sophisticated searches, well beyond what you might try to do with like a regex or, like that, and we'll kind of like touch on that as well. So, and then finally, some other things it's really good at that people don't realize is it's great at patching security vulnerabilities, right? Like upgrading dependencies. Sure, you've got Dependabot. If you've ever used Dependabot, I have a kind of a love-hate relationship with that thing because it just says, go upgrade your dependency, and it doesn't do anything else. It just says, there's a new version, go. And if you've ever been in a real-world environment, developers come in like, oh, I got a PR, we'll merge this, and it breaks because there's some sort of breaking change in the code, right? So like that's pretty common. So OpenRewrite goes a step further. It will upgrade dependencies, but it will also make changes to the code, fixing a lot of those breaking changes. So like it sounds easy. It's not. It's really, really hard because you want to maintain the formatting. You want to be idiomatically consistent with the code around it, right? If the code is using spaces, it should use spaces. If using tabs, it should use tabs. So there's a lot of stuff going on behind the scenes that people don't realize, and I'll try to point them out as we go through this. And then finally, who's heard of SonarQube? Or probably most people have used SonarQube. Static analysis tools. These are tools that wake up during your build and they say, you've got 80 days of tech debt because, you've got all these issues in the code. So another thing this is really good at is auto remediation. So instead of having SonarQube tell you have 80 days, what if you could have something that can remediate, like even if you remediate like 30% of that, you're going to reduce that without any human interaction. I will say some of the things that SonarQube reports, it's not easy to automate. So like, it's not something that can replace it totally, but it's certainly something that like can draw down that tech debt. Looks really good. Like, again, if you see a graph, where your tech debt goes from 80 days to like even 40 days, you're like, yes, So anyway, a lot of companies, they have SonarQube and then they ignore it. That's certainly true of many of the companies I've been at because they kind of deprioritize this stuff. It's only important when something serious happens, like a CV comes out, and then you're kind of stuck with this stuff. So anyway, and then the last piece of this is code mining and analysis. We're actually going to write a recipe today that kind of like does that, just kind of show off what you can do with the framework. So not just transformations, but just scraping data out of it in ways that are pretty meaningful. So, Okay, so first off, the community is quite large. There's tons and tons of recipes out here. Obviously, it started in Java, so you're going to find recipes for migrating from all the way from Java 8. I have 11 here, but the jump from 8 to 11 was really hard. And there's recipes to do that. As a matter of fact, that was one of the set of recipes I worked on when I was on the team. Spring Boot version updates, we're going to go through that. We have an example of that. We're going to take the pet clinic application from Spring 2.x and go up. Again, this is pretty normal. If you see OpenRewrite talks, you're going to see a ton of these. Like, look at me, update this framework. It's cool, but I think it's kind of like kind of regurgitating stuff that's already out there. So we'll try to like jump off after that. And then the other thing is there are other parsers out there besides Java, right? If you think about like a Spring app, well, it's got to have a YAML parser because you're going to have to change properties, right? So it knows how to parse YAML. It knows how to parse XML. It knows how to parse property files. So like when you start making these transformations, like I want to add a Spring property to, the dev environment, you can be very specific and say and target those things. So of course, if there's a YAML parser and you start using Kubernetes and everything is YAML, you can build semantic awareness on top of these parsers. So that's kind of what the community has done. So you will find there's a ton of recipes out there for like Kubernetes best practices. It is a parser for HCL, which is the language that's used by Terraform. So you can start seeing these type of transformations in like Terraform files. Less common, like newer stuff, they're actually working on a parser for Python. So obviously with all the AI stuff, that's becoming more important. There's a parser for TypeScript, which again, Python and TypeScript, I don't think are nearly as feature rich as what you're going to see with Java, but you will get the idea that if this is working in Java, this is kind of where they're going like in the next 5 years or so. I'd expect this, these other languages to kind of pick up as well. Okay, so at its core, this framework is just taking text-based source code. And again, I've got some code here. It doesn't need to be language specific. I mean, just imagine this could be XML. This could be, again, YAML, whatever. It's taking this and parsing it into a tree-like structure. That tree-like structure is not an abstract syntax tree. And this is kind of a comparison here. The abstract syntax tree is just the structure of the language. It says, is this a valid source file? So you could certainly have a Java file out there that is valid, like the compiler will, yeah, it's valid, but it may not have the correct type information. It's certainly like, so what, a compiler would typically do is it'll break it into this AST, and then it will start doing what's called type attribution. Again, a lot of this stuff kind of gets lost in these abstract syntax trees. They're usually just structure. So the lossless semantic tree, its two superpowers it's just a ton of data. All of the formatting, all of the white space, everything is embedded in the tree. So the tree is much bigger than a normal abstract syntax tree. In fact, it like has all these elements like prefix and right pad and left pad. And what that is doing, it's just scooping all the white space. If you can imagine what is valid Java, the tree has to represent it. So you'll find some very strange places where you can put annotations. Yeah.
So is this like one LST per language then? Or
one LST
per transformation
per source file. So like if you think of like and we'll go into that in a second. So each source file gets converted into these trees. Collectively, the parser knows about all of the other like information to do type attribution, right? Because again, we're wired into, in the case of Java, we're wired into the Java C compiler. We're actually going so far as like after the compiler has converted it to an AST and then done with this type attribution where it's matching all the types on the class path and it's kind of filling in this information into its abstract syntax tree. What OpenRewrite is doing is it walks that tree and it keeps track of each source file. And it has little, if you really look in there, what the parser is doing, it has a cursor position. And as it visits elements of the AST, it moves that cursor forward and it scoops out all the white space, all the documentation, and it shoves this all in this LST. And there's some pretty gnarly code in there that you can imagine. Like you have to be like precise. Like if you convert it to a tree and you spit it back out, it should not change at all, right? And it took quite a while to get these things to where you could do this reliably. So now no, there's a parsers, like I said, not just for Java, for XML, YAML, property files. And I guess like building on that, there's also a Groovy parser in there. And why is there a Groovy parser? We need to support Gradle as a build tool, right? If you're going to reliably say, I need to remove these dependencies or update these dependencies, you need to be able to make changes to all the build files, which are Groovy or Kotlin, right? So there's a Kotlin parser as well. So there's all these different parsers out there that are part of the ecosystem. And OpenRewrite has like if you're using just the open source products, the only thing it has right now are a build plugin for Maven and has a build plugin for Gradle. And these things will basically wake up and scan all of the files in the project and will pick up all these other things and assign parsers and do all that stuff. So like, even though there are parsers for Kotlin, it's actually firing off this parser inside like Java. So it's kind of like mind bending to get your head wrapped around because you'll have a parser inside a language that's already running. And so these parsers have to be seeded with ClassPass and all kinds of fun stuff. There is a company that I used to work for that is basically monetizing this at like the organization level. So you can imagine if you're using a build plugin, you can transform one project at a time. Modern's trying to monetize this by basically saying, okay, cool. We will scoop all of the source code across your entire org. We will convert it into LSTs and store that in a repo. Like they actually use Artifactory to just save this as extra artifacts. And then they have a way of basically running these things at scale, right? Like go run this upgrade across my entire org, right? Go generate PRs. You can do you can do like PR campaigns. So you kind of do things like what Dependabot does. You can also do some really cool like searches, right? Like if, for instance, the Log4Shell disaster that was a few years ago, am I vulnerable, right? Well, the parser for Maven and for Gradle are aware of transitive dependencies. It'd be really trivial to find out which things in your org are susceptible to that Log4Shell, like back in the day before everybody fixed it. If you could imagine all the hands on deck when that initially came out, how many hours were lost? A tool like this would have made it so much quicker to like resolve. And then of course, finding out you're vulnerable is one thing. A lot of security tools can do that. This can also remediate that too, like upgrade or exclude the dependency. So some pretty interesting like use cases. So as I said, the open source stuff is only available as a Maven plugin or a Gradle plugin. And I'll show you how it's really trivial to get this stuff to work in a Java project. Just know that it's not only just looking at Java stuff, it's scooping up every file underneath, that root, wherever the root POM is or the root Gradle file. It'll scoop up all property files, YAML, blah, blah, blah. So anyway, pretty neat. So all these different parsers are running inside the VM and they're converting them all to LSTs. The LSTs, in the case of the open source stuff, are all held in memory, right? So I mentioned there's a ton of data in there. So this can be kind of memory intensive if you have a large project. Modern solves this problem like a streaming API to kind of do this at scale. But it's still pretty good. And I've been able to run this on some very large Apache projects and it works fine. So just keep that in mind. Any questions so far?
Does it know the difference between a test folder and a...
It does, yeah. So it's aware of scopes, and that's a really good point, right? So just like the Java C compiler, right? You have a test scope and you have a compile scope, and they have different class paths. They have different sets of classes on them, and of course, all the parsers that are being used in OpenRewrite have to be aware of which scope they're in to compile those source files into LSTs that are accurately type attributed, right?
Yeah.
If you weren't aware of the test, source path, and you have like, Mockito as an example, it would still like build an LST, but all the type attribution would be gone. And so you'll find very quickly, like one of the superpowers of OpenRewrite is that type information. If you, like, I'm going to go through an example where I kind of demonstrate why type attribution is important, right? The LST has the structure of the source code. And I have two instances of called value. The class is called value. I have the Spring like property value thing where you can embed, a Spring property. And then I have Lombok value, which is another annotation. They're both annotations. And in the source code, they just, if you were to look at the simple name, they just says value, right? How do you know which one is which, right? So the type attribution is kind of embedded behind the scenes. That's how we can make these really sophisticated like transformations. We know the type is, the Lombok one. We know the type is Spring. Only make changes when it's that type, right? I think that one of the mistakes a lot of people make when they start working with this framework is they just kind of default to like, well, I've got the name here. It's in the AST. It's clear. It's there. I'll use that. That's the wrong thing to do. Like always, almost always, if I have to give you one hint, if you're working in this framework, always look for the type first, right? Also note the type can be null sometimes because sometimes type attribution doesn't work well. Another thing that we've covered, like we encountered a lot with the framework early on, is people going, well, I don't want to use a build plugin. I want to write my own, right? Because these parsers are out there. You can instantiate one and then try to seed it with its own class path. I discourage you from doing that because it's hard to get right? And like what I mean by that is like the build plugin for Maven, for instance, is hooked into Maven and is grabbing the class path from Maven. It's done all the work for you. You don't need to repeat it, right? So you could do it. If you had enough resources, you could certainly try to build your own CLI that could just scoop up anything anywhere and detect which language it is and try to figure it out. But I do not recommend it. Like the community's already built a lot of this stuff, so don't reinvent the wheel. But if you're really curious, I guess go ahead. Yeah, but there's a warning. So I know we have some people that are kind of newish to Java. So I'm gonna start with a Spring example. It's the classic pet clinic. So like if anybody has been around Java for a long time, there's Spring framework is ubiquitous. It's everywhere. Like almost all Java shops are going to have Spring. That's not to say that there aren't other frameworks. There are. There's Quarkus. I know that I'm missing some others. There's Micronaut. There are other frameworks that kind of do this sort of thing. Spring is by far the biggest like ecosystem that if you're doing enterprise Java, you're probably going to run into this. So we're going to start with a Spring app. We're going to start with a Spring app that's like running 2.1, I think, or 2.2. And we're going to just show how this framework is going to upgrade this. And if you had to do this by hand, you'd have to go through each version of Spring. You would have to go read the release notes and go, oh, this is breaking change. And if you've ever had to do this by hand and you're doing this in a larger project, it can take weeks. It literally can take weeks because you got to like make the changes, verify they still work, make sure nothing's broken, make sure all the tests pass. And then you've also got these other frameworks that also have to be upgraded along the way. If you make the jump from Spring Boot 2 to 3, or I'm sorry, 2.3 to 2.4, you have to move from JUnit 4 to JUnit 5, right? And that can be kind of like tedious and time consuming if you've ever had to do that. If you move to Spring Boot 3, you have to upgrade to at least like Java 17, which also includes you got to upgrade, the Java EE to Jakarta EE. There's all these other frameworks that you don't think about initially. So we'll start getting into how that is done in this with these recipes. So without further ado, we're going to just go in here. And again, this is not that interesting really, because if you look at OpenRewrite talks online, they're all going to kind of do this. Like a majority of them kind of do this. Let me know if this is too small or too big. So this is the Pet Clinic app. Oops, I was running a rewrite on this. Let's roll this back.
Question. So you will go from XML-based annotation?
Say again?
Are you going from XML-based to annotation-based?
Nope, this is already using annotation. So this is a Spring Boot app 2.x. So going from the XML representation would be more difficult. I think that by the time OpenRewrite had like really kind of gotten full swing, we were basically baseline on Java 8 and at least Spring Boot 1.5. So it was kind of after the days of the XML configuration. But I mean, could you do it? Yeah, it'd be hard. It'd be harder, I think. So, so anyway, I'm gonna go in here real quick and we're just gonna look at the POM. Sure enough, you know, you've got, you can see we're using 2.1.10. Okay, so you'll also see these little nasty yellow things here. I don't know if you've ever looked at these, but these are all of the CVEs. Let's see, that are where this thing is vulnerable. I'm trying to find one. There's a lot. I swear there's some. Yeah, maybe not as many. There we go. There's one that's got quite a few, right? So again, these all have like a score of like how severe they are. Obviously, the red ones are really severe. Like this is a 9.8. For those that don't know, Spring Boot, the Spring team only supports the latest 2-point releases of Java. Everything else you can get like a commercial contract, but they stop, you know, actively adding patches, including security patches for older versions of Spring Boot. Right now, Spring Boot is 3.3 or 3.4? 3.4? Yeah, 3.4. So 3.4 and 3.3 are really the only ones that are supported. So if you're not on those, you're out of security already. Like, and I would be willing to wager, because again, our organization has Spring Boot apps that are at, you know, like 2.x still. And we use X-Ray for our scanning. 48 CVs on average per project. It's like that's not a trivial amount. So why would you want to do this for that alone? You kind of want to do these upgrades. So all right, we're gonna start this app real quick, make sure it's running the way it's supposed to. Okay. There's the pet clinic. Again, if this is too small, let me know. So you can see we're running on 2.1. We're gonna go here real quick. Just make sure it's running. Localhost 8080A, there it is. So for those people that are new to Java that don't know this, this is the, you'll see this app, like this is kind of like their little like toy app. It's not, it's big enough. It's got some databases, right? So I can hit find, it's got information in there. And this is kind of like their example Spring app. We try to keep this up to date. Obviously, this is an older branch, and I did that for a reason. I want to kind of show off how you would do this, you know, how you would automate this, and kind of show you what type of things you can automate. So there it is. Works great. We're going to hit stop. So as I mentioned, OpenRewrite is just a plugin. Like this is it, right here. Actually, let me make this bigger. Okay, so yep. This is not that exciting. It's a plugin. This is the version we're using. These are the recipes we're going to run. I'll get into where I came up with this name. We'll get into where the catalog is and what type of recipes are out there. There's a lot of them. And then you can optionally set up dependencies that'll run for inside the context of this plugin, right? So like if you want to run Spring recipes, you better have the Spring recipes on the class path for the plugin. Again, the plugin's class path is different from the application's class path, right? Your application has different requirements, right? So what we're going to do now is we're just going to run this thing, right? Hopefully nothing breaks. Let's see, I'm in the wrong project. I got to put glasses on. Okay. Okay, cool. We're going to then basically launch this with Maven rewrite run. All right, so again, let's just remember what this thing is doing. You can see it's activating this recipe. The first thing this has got to do is got to go through and scan all the files in this project, right? So it's going to find them all, not just the Java files, but it's going to scoop up anything in here like these YAML files. Guess what? It's parsing those. It's parsing this POM XML. I think it has a markdown parser these days. If it doesn't, it won't be very long before they have one. So it's basically going through all of this stuff. It'll even mark files it doesn't know about as they call them. Basically, they're markers that know they exist, even though we don't have a parser for them. It also will just scoop things out that it knows that are text files, like the get ignore. It will basically snag that as well. What that means is once these things are parsed into LSTs, they're also open for search and transformation inside all the recipes. Okay. So this is done. It's warning, 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 warning. I don't know why they picked warning, but they did. And so what this is telling us is, hey, I changed this file and I told you there are a lot of recipes, right? So it's actually telling us which recipe made a change, like this no wired on constructor. This is a Spring rule that, and the newer version of Spring, you no longer have to use an auto wire annotation. So it's telling us why it made these changes. You can also see that there are other things that made the change. So just know it's there. I'll show you, I'm going to show you very briefly what Modern does in the UI to kind of like show this. It's, like this is kind of unwieldy to look at, but let's go look at the source here. Here are all the changes. So let's start with the POM. This is all automated without any human intervention. So first off, you can see that it upgraded the parent. You can see it added these two like compiler things. Again, let me make this bigger. Maybe. Okay. So the other thing that's kind of interesting about this, you'll notice that when it's upgrading dependencies, sometimes the dependencies might be expressed as a property, right? So like if you go down and found this in here, you'll actually find it's expressed as a property. So again, this gets back to the semantic awareness, right? Like I guess in a dumber tool, you would just write over the property with the actual version down in the embedded dependency. Because you have semantic awareness, you can actually travel and find the property and make the change there. So this starts giving you an idea of like some of the sophistication that you can do when you have semantic awareness of each file. Okay, so this is that interesting, like, changing the connector from Java to J. Okay, I didn't even know you needed to do that. I mentioned if we're going to Spring Boot 3, you have to go from, J2E to Jakarta. So this is basically saying, I want you to use EH cache, which is in-memory caching, but I want you to use the Jakarta version, right? So like some dependencies will have a classifier. So there'll be like a version that works with J2E and there'll be a version that works with Jakarta. There's a recipe that knows the difference and is making that change here. So these are things you have to do by hand and just discover like the hard way when you try to start the app and it doesn't run because it's using J2E versus Jakarta. And you oftentimes get errors that you're like, I don't even know what's going on here. So then you're doing Googling and fun stuff.
So if you got something like that, would you back up and rerun the transformation?
Yep. Well, like back in the day, there was no transformation. You just did it by hand, and then you had to figure out, oh, I got to go find this version of EH cache that works with Jakarta EE.
But now, if you make a mistake like that,
like you're gonna watch me do it. Like right now, I just ran it. Right, I'm gonna revert everything. We're gonna keep like doing this. So just wanted to again, that's kind of interesting. Like, so that's just the POM XML. Know that it will work with Gradle as well. It'll do the same sort of transformations with dependencies there. That's a lot harder because it's a language, not a static XML document. So it actually is parsing Groovy and Kotlin and doing some really sophisticated stuff to fix dependencies. Okay, so something else I want to kind of point out. We're going to go to this test. I mentioned when you go from Spring Boot 2.3 to 2.4, you have to go from JUnit 4 to 5. If you've ever had to do this by hand, it sucks. A lot of times you will, bust out your favorite set and regular expression, and you can get most of the way there. Things like, the before becomes before each. You can see the package name change. You could see that this would not be that hard to build like straight search and replace, but it's not going to do them all. And I'll show you an example of where this starts getting a little crazy. And then just another point out, something else that this is doing automated that's not obvious. It's, for a human, you're like, oh yeah, of course I'm going to use the same import order that the file is using, but that's what rewrite is doing as well. It's actually calculating like heuristics on the order of the import files and making sure it's putting the imports in the correct place. It sounds super easy for a human. It is a lot harder for something like a tool like this. There's no AI in play here. This is all just hard engineering to get right. You can see here it's smart enough to put the static imports down at the bottom because that's where the static imports were before. Like if you move the static import up here, it'll put it up there. So it's pretty neat. Let when you start thinking about what it's really doing. So again, then the inline stuff right here, right? Mockito extension instead of Mockito JUnit runner. This is just 4 to 5. And again, your AST, it just says Mockito extension, right? In this case, it's probably going to be, unambiguous. Okay. But how do we know? Well, again, the type information behind the scenes is telling us this, right? So we can make these things reliably. I want to show one that's kind of interesting. This is the break, like a proof that we can break regular expressions. This assert equals is being converted to a different order, right? You'll notice that it's reversing where the message should be, like if the assertion should fail. Good luck writing a regular expression that spans, 4 lines and does this type of reversal, right? So this kind of gives you an idea of like, this is whenever you feel like, like hold my beer, I can do this in the regular expression. I guarantee you this framework does it better. Yeah. So I just wanted to kind of like call that out. This is another fun one. Taking the parse exception rule, basically saying, I expect the parse exception to be thrown from a JUnit 4. This is how it was done in JUnit 4. JUnit 5 is using a lambda. It says assert throws. And you can see here, it's basically saying I expect to, like, this is not a non-trivial, like, again, try to write a regular expression that does this. Yeah, that's quite challenging. So you can see what's really doing is just taking the body of this method, it's wrapping it in a throws. And it's also using a static, again, that assert throw. Where did that come from? Yeah, it added it here, assert throws. So it actually is not only making that transformation, but it's also adding the import. And it's also formatting it. And that's the other thing that's like, that can be easily lost here, is you'll notice this thing indented the same way it was indented before. A lot of tools don't do that, right? A lot of tools aren't aware that this is going to be indented, however many spaces this happens to be, right? So again, what's happening here is OpenRewrite is keeping track of all of the indentation. It's creating heuristics of the most common patterns in here. And it uses that when it's formatting any new code it's adding. So you can imagine how hard it would be to get a PR across to a team when you've done this many changes if the source code didn't match what it looked like before, right? So it's a really hard problem. And there's no AI, again, no AI involved. This is just a lot of data and some pretty gnarly like algorithms underneath the covers. Okay, so neat. I'm going to do something else now. Now I mentioned, yeah.
If I wanted to go from, say, JUnit 4 to assert J for just for assertions, can you do stuff like that?
You must be reading my mind because let's go over here back to the POM. First of all, you were asking me, what do I do if I don't like what happened? Yeah, just roll it back. It's all automated, right? So I just did that. All changes gone. We're back now to 2.1. So happens right here, you can see I have a recipe that will take you from JUnit to assert J. Have you ever had to make this by hand? Have you ever had
Yeah,
it?
actually,
It sucks.
The last thing at work was
It's
going from
terrible.
2.7 to 3.3 or something.
All right, so let's do this. So now I'm running the upgrade for Spring Boot 3.3, and I'm also converting all the unit tests to use assert J. So
Does order matter?
no, that's a good point. So the way OpenRewrite works is once you load all of the recipes in, it's not obvious there are 2,700 recipes in the Spring Boot app alone. And what they do is OpenRewrite then basically just goes through those in order, and it keeps going through them. It goes through cycles until no more changes, right? So it can be a little bit confusing, like when you're doing development work. Why did this run a second time, right? Well, it ran a second time because it has to make sure no other changes happened. You can also short circuit it. You can say like, okay, if you get to like 6, just stop and fail, right? So you kind of put some limits on this. You don't want it to get into an endless loop. Very rarely does it do that, but it could, right? You could have one recipe changes something and one recipe changing it back, and those things could fight. You can see a world where that might be kind of a problem. So, okay, so let's go ahead and run this real quick. I have a really fast MacBook Pro 3, so again, it might go a little slower on like a older machines, work machines. But again, just keep in mind it's It's parsing these things into LSTs each time. So it's kind of slow, or it can be slow, or preserved as slow, especially on larger projects. Just be patient with it. It's well worth it. Like, again, you're going to see in a second. Let's go look at this. Let's go look at that same test now. Okay, so now you can see it's taking the JUnit asserts, that's gone. And it's now using assert that, which is an assert J thing. You'll also notice that it's got the exception of type. You can already see where this is going, that one place where we have a rule where we're trying to catch an exception. It's converted to the assert J of doing things. So let's go back through this. So you can see here, it's now assert equals is being converted to assert that. And you can see that it's going from, this to this more fluent API where it's like that. So it's reversing arguments. Again, you could probably write a regular expression to do this if it's on the same line. Things are going to go south quickly when you get to this. Now, why is this all in one line? It fits, right? So again, if it doesn't see that it needs to do a line wrap, then it's not going to. So it basically just flattened this out. So what's great about this is it made this change. You're still a developer. You still have to commit, submit a PR. So you can come in here and I guess you can go in here and change this the way you like it, right? It doesn't have to be just this the way it is. A lot of times these recipes will get you like 90–95% of the way there, and you might still need to give it a little finesse to get it across the finish line, but it will save you a ton of time. And then again, this is kind of a fun one. This is again taking this expected exception, takes the annotation off. It uses the assert J version of this, which is basically saying, I expect a exception of this type is thrown from this, thing. Yeah. So pretty nifty. And again, that's again, another thing that's not obvious here is these recipes are composable. It's kind of obvious. You look at this. If you look at this, you can clearly see like these recipes are like nested very, very deeply. I am in no way plugging my old company, but I am going to show this off because it's a really cool visual. Okay, I mentioned. I'll just sign in real quick. Okay, this is a cool visualization. You can see here there are 2,819 recipes that are built up of this migrate to Spring Boot 3.3. If I open this up, you can see it's nested with the migration to Spring Boot 3.2. And you can imagine how this goes. And 3.1, and 3.0, and 2.7, right? It just keeps going back and back and back. So what you're seeing here in this tool, like, well, there's a big cluster of changes. What's going on here? Yep, this is changing all the property keys that have changed in the Spring framework for whatever damn version we're looking at. So this is from a Spring Boot 1 to 2 migration, right? These are all the recipes that are, again, this is community driven. What's great about this is these recipes get better over time because it's open source and the community is constantly adding to this. So they're currently working on Spring Boot 3.4. Guaranteed there's probably something on the board already where they're working on this. And that one will extend all this 3.3 stuff. So you can imagine that, again, so my machine right now is running all of these recipes individually on the source code, like on those LSTs, as part of this run. Okay. Some of the other things that are not obvious here, again, like in Spring Boot 3, there should be an upgrade to Jakarta. Yep. There should be an upgrade to Java 17, I would hope. Somewhere in here. It's going to be buried. I promise it's in there somewhere. So this is the baseline became Java 17. So we have to move to Java 17. Some of the other features I didn't even kind of touch on here, like there are a lot of files that were changed here. Let's just go look at a couple of these. So you can see there's that Jakarta, JavaX to Jakarta is being done here. Let's go to like Jakarta JE. What did it change here? Nothing of consequence. Controller. So again, using JavaX to Jakarta and going to is valid. Oh, look, we don't need an auto wire on the constructor anymore, right? So not only will this do that, it'll also do best practices too. Oh, I know one that's kind of interesting that I probably kind of glossed over. You don't need to have a public public on your test in JUnit 5. So you can see here, kind of subtly, kind of like it's getting rid of that as well. You'll also notice it's taking off the test off the beginning of this thing. You don't need to prefix everything with test, right? So it's doing all of this automated. Again, good luck doing this by hand. It can take weeks. Yeah, and it did take weeks back in the day.
Oh,
If-
I did it.
If anybody's done it, it's pretty hard.
To
Yeah.
7 to
Yep.
3, I think.
Okay, any questions so far? Everybody with me?
You mentioned there's no AI. Is there no generative? This is not generative AI at all.
There's no generative AI at play in anything we've done so far. I will tell you that Modern is working on extensions that will use AI to kind of like, again, I've not been involved in that. I can tell you that Amazon Q, you might hear this project called Amazon Q, which is like a tool they use to help migrate things in AWS. Underneath the covers, it's using AI, but it also is using OpenRewrite because guess what? These source code modifications can't be hallucinations, right? You can't do this with AI.
Right.
You will not get the results you want, right? So what's happening in these AI tools, and they don't really tell you this, these AI tools are when they have to make the code transformations, then fall back to OpenRewrite to do it with precision, right? So that's kind of how that's working. Microsoft has a very similar tool for Azure. And again, they don't really tell you that, but that's what's happening. You'll also see there's a Spring Boot migrator, which is from VMware. That is also using OpenRewrite. There's no AI in that one. It's just, like rebranding this. So it'll be interesting to see how this works out in the next couple of years. I can tell you the licensing on a lot of these recipes changed, which was very surprising to me. And it's because Modern is trying to protect themselves from somebody like Amazon coming in and just, scooping everything up. Yep. So, yeah.
You mentioned earlier that one of the problems that OpenRewrite can run into is that it loops because of contradicting policies.
Yep.
Does it have any default mechanisms to notice when that's happening and stop, or does it just keep going?
It basically will stop after I forget how many cycles. So again, what's happening here is it parses everything into LSTs. It then takes all the recipes and it loops through all of those LSTs with all the recipes, right? So you can imagine 2,000 times 100 or 200 source files. That's a small project. If you get to thousands, like that's a lot of work. And so what's going to happen? It's going to go through all of those once. Going to go through it again. If there's no changes, it's going to stop. If there are more changes, it'll keep going, right? So you can imagine, like sometimes your recipe may not make a change until like the third cycle because it's waiting on other recipes to make a change, like that assert J thing, for instance. It has to wait for the JUnit 4 to 5 to make that change. So it'll pick up the type for JUnit 5 so it can then convert it to assert J. It's not obvious, but that's what's happening behind the scenes. So to answer your question, there's a limit on how many cycles it'll do before it just stops. And so sometimes you might have to adjust that. I think there's a preference somewhere, I forget, it's been a while, where you can tell it how many cycles to run when it's doing recipe execution. It may be valid to like bump that up to 20 or, like again, but you might be waiting there for days. So just be careful.
Seriously, dudes?
Yeah.
Regarding size for a large project, since the LST is only being kept in memory, do you run into issues where you just can't do it? Maybe do an incremental change here and then another incremental change in order to get everything.
That's a good question. The answer is early on, we ran into that issue. This has become more memory efficient over time. There are some crazy stuff we had to do in there. Like it uses referential integrity versus like object equality to like make sure we don't duplicate things, right? It's very careful. Like the LSTs themselves are all immutable for a reason, right? And it's kind of interesting. Like you think about like, how is that efficient, right? Like if you're like way, way, way down this LST and you make a change there, it copies it to the parent and then it mutates that copy. So again, it's immutable. So it's just generating new objects all the way up the tree. So like by the time you get all the way to the source file, you have a new source file, you have a new tree, like the entire branch has new objects, right? So it is really incredibly efficient for what it does. Haven't run into too many issues with memory, but again, like running on a 32 gig, MacBook Pro, like if you're trying to do this on like some constrained hardware, if you're doing this in a CI environment, like in AKS, you might run into some issues, right? If you only allocate one CPU and like a limited amount of memory, you definitely run into issues, right? So the one, again, the open source stuff is kind of like the, like the gateway drug, right? And then what Modern is doing to monetize this is they break it up into 2 stages. They generate LSTs and they serialize them to disk, or they serialize them as an artifact. That actually is really hard because think about what that tree, it's a tree, but the type system is cyclic and has loops. And, like you can imagine, this thing is a Java list with a string in it. No, it's a Java list with a integer in it, right? Those are different types, right? And so the entire type system is aware of that. So the serialization of LSTs, if you have the inclination to go try it, it's hard, not impossible. You can't just say, hey, JSON, I want you to go ahead and not, every time you run into a duplicate, just make a reference ID. It's not quite that simple. It doesn't work well. Had to do some pretty crazy things in there to get this thing to serialize the disk. It's not impossible, obviously. Once you do that, then you can stream these things and do it at scale.
Does it naturally work well with parallelization for the
It
project?
does. It does. You can think about this. You can make transformations on a per LST basis, right? I have to think about this now. If you change an LST and you had a reference to that LST somewhere else, in like the same set of source files, you might run into some interesting issues there, to be honest. I will tell you, for instance, one of the things that you're going to see, and we'll see in a second what these LSTs look like. They're quite complicated. Do not try to build them by hand. Your instinct will go, I can just construct this thing, and you'll get it wrong. Guaranteed. There's too much information. Again, you can build the LST, the LST, but are you getting the type attribution right? Have you set the right type information on here? And it's recursive and nested, and it's pretty gnarly to get right. So, I'm going to show you there's a lot of building blocks. That's the other thing I want to show. The recipe catalog. That's one thing I forgot to talk about. How many, obviously there's 2,000 recipes, cool. I can use Modern's, sure, we'll use that. Just know that if you go to docs.openrewrite.org, this is the document, and this is linked from the GitHub project. There is a recipe catalog here. And you can see there are some AI related recipes. I don't even know what the things are doing. So I'm going to just skip over that because I'm not going to pretend to be an expert in that. But you can see there are other things in here like C#. Good Lord. I'm not sure when they added that. .NET. Okay, sure. What is interesting is I know there's a COBOL out here somewhere. Yeah, I know this because they were building this. COBOL is a gnarly language. There's where Java has maybe 40 or 50 syntax elements, COBOL has 600. It's insane. Yeah. So there are definitely parsers for that, but I just want to kind of point out that this isn't just Java anymore. And you can see there's Node.js. They've got some kind of interesting in Quarkus. And again, all these XML, I kind of want to touch on this right here. I mentioned there are building blocks, right? So you imagine, okay, Maven is just an XML document behind the scenes. It's built on all these building block XML recipes, right? Add a comment to a tag. You can do that with, a recipe here. Or you can change an attribute, change a tag name, some very basic things here. If we go to Java, so that's that's another one of my hints. If you're building your own recipes, almost always check the recipe catalog first because there's likely somebody's already written one or there's something very similar, and you can go look at the source code and see how they did it, right? Like some of the stuff is really hard to get right because again, it's kind of a complicated framework. I'm not even going to pretend to say that this is an easy framework to learn off the bat. It can be challenging at first. The learning curve is steep, but the rewards are pretty big once you get there. So you can see here, there are recipes for adding dependencies. There are recipes for removing them. I guarantee it somewhere. Yep, remove dependency, right? So again, these are pre-built building blocks. You can declaratively add these to a composite recipe. We'll get into that in a second. I'll actually show how that's done. So there's a huge catalog out there. Know that this is Maven, right? But guess what? There's Gradle out there too. And you're going to find there's add Gradle dependency. So when you are using the Java add dependency, it's delegating to the Gradle and the Java dependency. So it will make changes in either one, right? So there are a ton of building blocks. You will find that, like, for instance, when we're operationalizing our stuff at A51, I would say 80% of the work I've done so far has been declarative, meaning I haven't had to write my own recipe code, which we will do here. But most of it you can do declaratively. Remove this dependency, add this property, swap this property. Once you start getting into rewrite this source code, that's when you start dealing with your own recipes. Although I do want to point out there's some really interesting Java recipe building blocks that you can even kind of get away with not having to do these. If you can, it's better. For instance, I think there's a change type, change method access level, right? Change it from public to private to protected, right? Changing the method name. So if it's a straightforward, just a method rename, that's pretty easy to do. Change type. So yeah, here's the old qualified thing. Here's the new qualified thing, right? If you think about it, you're like, oh my God, how's that going to work, right? What happens if the new type doesn't have all these methods on it, right? So what's happened is your LST starts having like kind of interesting patterns, right? Where your recipe, you're switching the type. So now all of a sudden your new type still has all these method references that are still using the old type. So you can actually say, go look at the new type at this method that I know doesn't exist, but used to exist, and go ahead and change its name. So you can kind of get away with doing some really weird finessing there. So you don't have to write your own recipes. It's not obvious at all. But anyway. So also formatting. If you find yourself ever writing a recipe, and again, this will happen to everybody. I'm sure it happened to you, Sean, when you're out there. You're going to like run a recipe and it's not going to format it right. You're going to like, why didn't it put a space here? Or why is there no space? Or why is there extra tabs? The typical, like your quick and dirty thing is you're fine. I'm just going to add a space here. I'm just going to say, go find the prefix in the tree. And I'm just going to say, add a space. And that happened a lot early on. Don't do that. like there are tools in the framework to basically kind of like scope, say, like, I want you to format this branch of the tree. I want you to use all the formatting rules. It's much better to do it that way because it's going to get it right. Right. So almost always it can be tricky to kind of get right initially. You're like, I don't understand why it's not formatting something. Stick with it. Always use auto format from the tools. Don't try your own. Okay. All right. So the next kind of interesting thought exercise here. I wanted to kind of mention this. I mentioned okay, so we're using the out of the box Spring Boot experience, and we did this assert J thing. We kind of proved that we do that. First of all, let's just go ahead and okay, we've rolled back all the changes. Good. All right. So what I'm going to do now, I'm going to comment out that one, and I'm going to uncomment this one, which is now org sample upgrade Spring Boot. Right. So clearly this is a custom recipe that's going to do the same thing. So where the hell is this coming from? Okay. I mentioned when you build the plugin, you can actually put additional dependencies on here. You can see here, I have org sample rewrite sandbox. So this thing is going to be on the class path of the plugin. I just so happen to have both projects open in IntelliJ. So I've got the sandbox over here. And I just kind of want to touch on what this looks like on this side. So this is the actual recipe. It's declarative. If I go into the main resources, meta INF rewrite, you'll see I have custom Spring. There it is. Org sample Spring Boot. And you can see that I can make this any arbitrary number of recipes I want. So what am I doing? I'm saying, cool, I'm going to steal all of the recipes, all 2,900 and whatever, however many there were, from the default org, and I'm going to go ahead and upgrade Guava because why not, right? So then you're like, well, where does this upgrade Guava come from? Guess what? There's a declarative recipe for that. And this recipe is using the building block for Java to upgrade a dependency. And you will notice that the new version is 33.x. So even though I'm changing Maven like based, dependency here, rewrite is smart enough to use these .x's to like find the most current patch version, right? So it's kind of handy. This is kind of like stolen from the way Gradle worked. Gradle allows you to do this sort of thing, same sort of thing. I think you could also just use latest if you don't care about the major version. You could even do that. I picked Guava because it also has -JRE on the end, just a proof that yes, indeed, you can like upgrade dependencies like that. So that's what this recipe looks like. So I'm running this custom upgrade, which is including this Guava thing. And let's go back over to this. Okay, we're running our upgrade. Let's go ahead and fire this off. Guess what? It's going to do the same exact thing that we were doing before, but we now are going to hopefully upgrade Guava in addition to everything else, right? So you can start seeing why if you had a bunch of company libraries that are on older versions of Spring, or like they rely on older versions of Spring and you have an upgrade path for those to go use a new version, you can upgrade those dependencies, your company libraries, just as well as everything else. You're just doing the same thing that the community recipes are doing. So if I go back to the pet clinic and we go into the Palm and make this bigger. And again, I did this on purpose. I put Guava as a property, so I express this as a property. So this is just to kind of point out that the framework is smart enough to follow property references to their source and make the change there. So sure enough, it did. It upgraded it to 33.4.0, which if you go out of Maven Central, that's the most current version of this version. So what is it doing behind the scenes? It's actually downloading all the POM XMLs. It is aware of all the dependencies. It can download like all the versions and store them. It's actually storing them in a RocksDB database behind the scenes. I know this because I wrote it. It's terrible. So anyway, there's kind of like just wanted to kind of point out that declarative recipes are very powerful and you can do a lot of stuff. You can be a hero in your company pretty quick by doing these sort of transformations, right? My recommendation is do a transformation once by hand, a migration by one. Like if you've got hundreds, do one by hand. Take notes. Think about things like, especially dependency, like updates. Go ahead and you record those. Another really easy one is, we'll get into that, is we had some Spring libraries that were no longer used. We just removed them. And as part of that, they had all these Spring properties in there. And we're like, well, how do we know which ones to remove? And it's very tedious. You have to go and look through all the source code. And again, if you've ever used Spring Framework before, you can use like the modern way is you have configuration properties, which are strongly typed objects that are used by Spring to find properties. But there is @value, which is a string. You can put your property in there. And so, of course, if you miss one, you're not going to guarantee to remove everything, right? So you'll have these properties showing up and people are like, what the hell does this thing do? Do we use it anymore, right? So that's where we're going to get into like our first recipe development, like for real. So that was something, well, actually, I'll take that back. We're going to go through a transformation one first. I just want to show like, this is declarative recipes. So cool. Let me shut this down for a bit. Okay. Back to the sandbox. This is a Spring Boot. Sorry, this is a Maven project that was cloned. And I want to like point this out, and I will leave a link to this in the meeting notes on Meetup. There is, again, don't be scared, it's Modarin's recipe starter. What this is you can see how this says uses this template. You can basically clone this to your own repo. And this is basically going to set up the entire development environment for developing recipes. You'll notice there's Gradle and there's also Maven. So basically whatever build framework you want to use. Sorry, if you're using Bazel, you're out of luck. Use one of these two. And then what I ended up doing is, for the sake of just, I don't like Gradle very well. I mean, Gradle's fine, but it's a lot easier to express like how this stuff's done in Maven. So I picked Maven. Okay. So with that said, I basically cloned this thing and you can see all the Gradle stuff is gone. And I just have, I basically have a Maven POM file. Okay, what's this look like real quick? I don't need to get into too much detail. We use Lombok just for the sake of just less typing. You'll notice that there are all these dependencies come with a template, but you can see rewrite Java, rewrite YAML, rewrite Spring, test. You know, there's a bunch of stuff already here for us. So basically this gives you all those building block recipes out of the gate. And then we're gonna work on a test real quick. The sandbox has a bunch of examples, so I recommend going through them and like just kind of checking them out. If this really interests you, it may not. You might go like, I'm not doing this. I'll never do this again. But for now, we're gonna check it out. So this is kind of an interesting. I'm always gonna say like start with the tests, right? So rewrite comes with a testing harness, which is it's honestly really fabulous. There's also another really kind of curious thing here. You will notice I'm using multi-line strings here. So I have to be using a version of Java that allows multi-line strings, right? However, your recipe is going to likely run on something that doesn't support multi-line strings, right? You're going to run on old Java 8, doesn't have it, or even Java 11, there's no multi-line strings. So one of the kind of like subtle things you might miss if you're not careful is the testing. Let's see, where the hell is that? Maybe it's down here in the compiler. There we go. The test path is on Java 17 and the compile path is on Java 8. What that means is when you're developing recipes, stick to Java 8. It won't, well, again, if the IDE is not going to let you do this if you've got this set up correctly. But you want to use Java 17 for the very reason that you're writing code that rewrites code. So you don't really want to have to like express code with a bunch of inline strings with pluses, right? So that's the reason it is done this way. And the way the test harness works is pretty simple. You'll notice it's actually an interface with a bunch of default methods. So for those people that haven't used Java in a long time, interfaces can have default methods in them right here. So you can actually put a method body in here. So unless you override it, this is the version it's going to use. So we're kind of leveraging that aspect in the test harness. Okay, so what do you do here? One of the most common things you will do is like if you want to set up the recipe like testing specs across all of your tests that are run this file, you override defaults. Duh. And you can see here, this is kind of a Fluent API. You're basically saying, I want you to run this recipe. I want to create this recipe. Here's a parser I want to use for Java. This looks a little confusing at first. Now remember, the parser is something that's running instantiated by another. It knows nothing about the class path on which it's running. It doesn't know anything about your test class path. It doesn't know anything about the runtime class path. All it knows is it's a parser and it knows how to parse Java, just pure Java, nothing else. So if you're going to build a parser and you're going to reference any types that are not in the Java lang, you must explicitly set them on the class path somehow, right? In the parser. So it's kind of like a level abstraction that have to get your head wrapped around. Whenever you use a parser, just remember you have to like add something to the class path. So if we're going to start touching on Guava, so again, what is this parser doing? This parser, in this case, is parsing this before source, right? Another fun fact, notice how you're getting like content assistant here. It actually recognizes this string as a Java file. This is something that I didn't know until I joined Modern. This little guy right here, this little comment is an IntelliJ shortcut for basically saying the contents of the string are actually a Java app or a Java file. You can do that for XML. You can do that for a lot of things, YAML. So that's kind of like one of those things, like you just take one thing out of this thing. If you're not going to use this framework, know that IntelliJ, you can comment this thing and it's pretty neat. So you can see we're importing, Google comment. And again, why is this important? We have to get type attribution right? We need to know that this list is coming from the Google Common collection, right? If I didn't know this, if I didn't put this import in here, the compiler or the parser will still parse it into an LST. It'll still look okay, but it won't have any type information. It'll be null, right? And if you turn on the warnings, and again, I'll show that, you'll see warnings, but it'll still generate the LSTs. What's going to happen though is the recipe's not going to work because the recipe's checking for the type information, right? So one of the superpowers of rewrite is type information. So you kind of have to go through some hoops to make sure the types are there whenever you're parsing a chunk of code. That's why I say don't do it yourself. Like the Maven plugin is smart enough to set up the parsers based on the entire Maven configuration, right? Or the Gradle configuration. So you don't have to do it. Trying to do this by hand is hard. So, okay. So what's happening here, this test harness is basically saying, okay, given this little chunk of source code, this is a really simple Java source file. We basically are looking for this list array to be replaced with, all right, new array list. Makes sense, right? So again, always start with the test. This is where you create a before and after. This is what I expect, and then write a recipe that does that. And then again, you'll see here we've got some other test cases. Here's one where there's a number, and here's one where there's another number, and different like methods. Okay, so what should happen here is if I run one of these, again, the test harness is this is not gonna be surprising. Okay, cool. It turned green. One other thing that I want to point out is what in the hell is all this? Make this bigger. Maybe. There we go. This recipe is actually printing out the entire LST, like the elements of an LST, just to give you an idea of how complicated this thing can get fast, right? And this is not printing all the other elements that are sitting in between these things. Like there are things that are holding white space. There are things that are holding comments. This just gives you an idea, like trying to construct this stuff by hand is hard. This is just here to demonstrate like this can be really challenging to work with. We're going to get into how this the framework walks these trees very quickly. So, okay. Okay. Now let's see if I can get this back down. Nope. Okay, there we go. Okay. So anyway, this should not be surprising, right? Like if I had an extra space here, right? Again, we take the space stuff serious. This test will fail, or it should fail. If I go here and look at the difference. Yep, sure enough, there's an extra space, right? So like this is the level of assertions we're making to make sure the source code matches what it should, right? So framework's pretty good at that. Okay, so that's the test. So what the hell does this thing actually look like? Let's go look at the actual recipe now. Maybe. I don't know how we're doing on time. Okay. A recipe, we've already kind of determined a recipe is this thing that can do some work and also can contain other recipes, right? So what we've done here is we don't really have any nested recipes. Just trust me, there are ways to do it. I'm not gonna get into it here. But what we're doing is a recipe always has a couple of metadata. So this is if you were to publish this in OpenRewrite or submit this as a PR, all of this like metadata here, like what's the display name, what's the description, all of that's going to show up in the docs on the recipe catalogs, right? So there's actually some pretty gnarly rules in here. Like if you try to run this test, and for instance, you forget to put a period on the end of this description, the testing harness will bark at you, right? So it's trying to make sure that all the recipes kind of follow the same like pattern. Okay. So what's going on here is a recipe is going to delegate to a visitor. A visitor pattern. I don't know if people are familiar with visitor pattern. What this is going to do is it's basically going to start at the top level of each tree. So again, a tree equals one source file. And it's going to walk that tree. And the visitor is polymorphic and recursive and will go infinitely deep, and all the weird language constructs you can come up with when you write, like a source file, this visitor knows how to navigate it. So what's going on in here? You'll also notice there's this preconditions check. I'm not going to touch on this too much, but basically you can say, I don't even want you to run this visitor. I don't want you to take all the CPU cycles to go over the source file if you don't meet these preconditions, right? I don't want you to change anything if you're not using these types, for instance, right? And this is really quite fast and cached, right? These use methods. So basically this is kind of like an optimization here. This is just taken from the examples, so they're well documented. So just kind of like take a peek at this. I mentioned you don't want to write this code by yourself. You don't want to write your your trees. So what the framework provides is a thing called a Java template, which, hey, that's Java code. It's a little snippet of Java code, but it's Java code. what this template is going to do. And you'll notice, again, there's a parser behind the scenes that's going to take this Java code and convert it into it. You have to have a parser somewhere. You have to tell it which types you're going to use in this piece of code. If you're introducing new types, you got to do this. You'll see that they all are the same. You can see that it's basically looking for a new array list. It's looking for, sure, okay, take a number or takes a collection, any collection. Basically, I'm not going to get into too much detail here. The template I could probably spend a whole hour on. But this thing, all this is doing is taking little snippets of Java code. You are inserting it into wherever you happen to be like replacing it. There's like coordinates in the source code. It basically then walks backwards and constructs a Java file out of it and compiles it with a parser. It is crazy code. It took 2 years to get right. And we rewrote it like 3 or 4 times, right? So pretty challenging because what it has to do is it has to be compiled in the context that wherever you happen to replace it. So if we're replacing a Guava list, we need to compile this where that thing would have been, right? And then we have to scoop up all the types around it. And very challenging. Okay. So I mentioned this thing was printing the tree. This is what's happening at the when we get to again, the way this works is the compilation unit is the top level tree element. It almost always is. From there, you can see that there's a call to super. This is what says go navigate down the rest of the tree. If I did not do this, if I just returned the CU, it's not going to navigate the rest of the tree at all. So the visitor is what navigates the whole tree. It's hard to get right too. So when you basically, what we're doing here is we're basically overriding when you visit certain syntax elements within the Java language. So you can see here, we're basically saying whenever we visit a method invocation. So there are going to be a bunch of method invocations here, right? Like it's not going to just be this Guava one, but anytime you have a method invocation anywhere, it's going to call this, right? So you can see it's using this, hey, does this method match? So again, given the method I'm currently visiting, does it match this pattern, right? So like the framework provides these method matchers here. You can kind of start seeing where this is going. So basically we're only gonna make the change if we match these things. Okay. So what this is doing is it's basically saying when I find a method invocation, if it's one of these Guava types, I want you to go ahead and maybe remove the import. Now, again, this is kind of an interesting thing. Why is it maybe? What happens if there are other types that are not something we can replace it with? So what this is going to do is it's going to mark the thing as maybe I'm going to remove it. What's going to happen is when it gets back to the top level, it's going to scan to see if there are any types remaining. And if there are no longer any types, go ahead and remove it, right? This is not stuff you want to write by hand. The framework does it very well. Right. And then there's also maybe add import. What if it already exists? There's no need to add it a second time, but you certainly could. Right. So that's what these maybe, that's why it says maybe. Smart enough to kind of like conditionally do it based on what's already there. And then I mentioned this, wherever this method here, go ahead and apply this new array list. This is a template. So this is that template and has a Java code. Apply it at the current cursor. I'm going to get into what a cursor is here in a second. And the coordinates here in this case are replace. So again, this is the method. And there's a get coordinate and there's a replace. There are other things. You can replace just the methods inside the method invocation, right? So like, let's say that you have a snippet of code that's really just a list of arguments and you want to reorder them. You could say instead, here's a snippet of just arguments, literally just arguments, comma separated. And it will go through and try to compile that with the existing code around it, right? So you can do some really interesting and crazy things here. So that's what these coordinates are for, is like they're more specific places telling the template, this is where I want you to target. Go ahead and build a Java class around me until I can compile it. Also, I can just extract the little LST elements and insert them in here. It's doing a ton of work. And I don't expect most people here have yet. Again, it took me, probably a year before I really got comfortable with this visitor pattern and what was going on in here. But it is not like, again, this is not rocket science here, right? This is not doing a lot. And that's it. That's the entire recipe. That's what's replacing all the Guava elements throughout. So if I had this Guava list thing, I could run this on a very large project and would go through and reliably replace all of these things. Pretty neat. Okay. I am running out of time, so I'm going to do this very quick, hopefully. I mentioned I had a problem at work where I wanted to figure out all the properties that are used in an old library that I no longer need, so I can go ahead and remove them. Well, how do I catalog that? So we're going to switch gears and figure out, well, like, could we write a recipe that is doing like a semantic search? And could it reach into these inline things, right? Source code, it's a quote. There's going to be properties embedded in that. Can I actually do that? So the answer is yes. So what this is doing is if I go back to my test, I always start with the test. Okay, so you can see here, we actually have a recipe called find inline Spring Boot properties. You can see we're using a Java parser again. I mentioned that you always need to make sure that the parser you're going to use, and again, this parser here is going to parse this source code in our tests. So we have to make it aware of any types we're going to encounter. And you will see I'm not using anything from the class path. I'm using this thing called depends on. This depends on takes strings. And these strings are literally just Java source code. And what I've done is I went to the source for these annotations and I just extracted the source code and I put them in a string. That's literally all I did. This is more space efficient than like if you think about this, you can either put it on the class path and you can certainly add it there. And in case of tests, that's fine. But you can also do this parsing stuff inside a recipe and you don't want to embed, half a meg jar file inside your other jar file so you can grab one class out of here. So this is a case where, cool, I'll just write a stub. A stub is just the public facing interface that I need to get type information. That is it. So this is kind of like one of those hidden things that you're not aware of initially. You're like, well, how do I set these types up? This is the way to do it. There's an ability to also set up the parser. I want to hit control space real quick. You can see here class path. So literally look at the class path, the gigantic list of jar files, and extract just the jar file I want. That works fine so long as it's on the class path, right? You can imagine if you're running this, running test, you're going to be fine. But if you're running in a recipe and you try this, the runtime class path will not have your jar file. It will not. So the way they solve that problem is you can say class path from resource. You can literally take a jar file, put it in the resource folder under a special directory and put the jar file there and then load it from there. And I'll show an example of that maybe if I have time. A lot like the rewrite Spring. You can imagine all those versions of Spring, 2.5, 2.6, 2.7. They have to have jar files for each one of those. So that also means that that recipe jar is gigantic because it has all these like dependencies in them. So anyway, depends on, it's kind of a quick way and dirty way. I just want to like touch this real quick. So what we're basically doing here is you can see that there's this thing called a data table. A data table is basically a kind of like a thing that sits at the visitor level, and it's like an accumulator. So as you visit a tree, your accumulator is always there. So you can basically take that and insert rows as you encounter things as you visit elements in your tree. So knowing that I'm looking for two very specific annotations. So I want to like start here. This is using the value annotation, and I did this on purpose. You'll notice there's Lombok value and there's also value, right? So I have the Spring value and I have this. So these types, like when you look at the LST elements and you say, give me your simple name, they're both going to say value. There's no way to tell the difference. The type information, like again, you say get type. That's how we differentiate between the two. So what I'm doing here is I'm trying to find this annotation. I'm trying to extract this property and I want to put it in this data table in this accumulator, right? And I want to do that every time I visit any annotation. And then very similarly, if I'm down here, let's see, this is kind of a fun one too. A value can have conditions in it. First, look for this property. If that property is not there, then this colon annotate, basically this colon saying this is the default if you can't find my property. In this case, we have another property. And then if we can't find that, then this is the default value. I need to be able to scoop out all the properties in here. And again, parse this. Also, you could just as easily do something like this. You could have like, this is also valid. right? So there's actually a little parser in here. Actually Rewrite has one. We just happen to use it for the Maven stuff, but it works just as well for this stuff. So I kind of like piggyback this. So like there's almost always something in the framework that can help you with these tasks. And if you have questions, ask the community. There's like a Slack channel for it. Sean, I'm sure you've done that a lot over the years. So anyway, finally, let's go look at this recipe real quick. What does this thing look like? This is not gonna be all that surprising. This is again a recipe. This is where we're setting up that report, right? This is the Spring Boot property report. This, if I go and look at this, this is a data table. And so there's a method inside this, sure, somewhere. I forgot how. Ah, there we go. Passes this to it. Okay. The framework's aware of it. Trust me, it works. I promise. And what this allows you to do is as you, again, with your Java visitor, when you visit an annotation, what you can see what we're doing here, we're basically saying, given this LST element, which is an annotation, we're calling get type. That's key. The get type, we're basically saying, is it this fully qualified Spring thing? And if it is, cool. I'm going to go ahead and try to extract the properties out of this thing. Let's go look at this extract properties real quick. Again, working with the stuff, there's not a lot of code here. There's only like, there's only like a couple hundred lines of code in here. But trying to come up with this can be a little bit tricky, right? Turns out you can have more than one property in here. That's why it's returning a set. You can see we're grabbing the arguments in here. If we find an argument, a value only has a single argument. So we're coming in here. We're grabbing basically the string right here. And then we're using that placeholder parser to go and extract all the names out of it. And then you can see here, we're adding it to the properties, and at the bottom of this thing, return the properties. And then what is this doing with its properties? It is taking each one and inserting a row in that thing. Okay. And then very similar, if this is one of these conditional on property annotations, this is actually a little bit trickier because if you look at the conditional on property, let's see if it has several arguments in the annotation, right? You can use the default, or you can use name, or you can use prefix, and you can use prefix, and the name is also a set of them. So you can actually have more than one property in there. I don't know if people knew that or not. So again, this gets to be a little bit tricky. So this is what all this is doing is basically going through all the arguments. Again, this is the LST arguments, and it's basically saying, hey, if it's a literal, cool, meaning a string literal, cool, I know how to extract a value out of that. If it's an assignment, meaning name equals a string literal, then it knows how to do that. What about if it was a constant? What if it's, a constant and the constant's defined somewhere else in your source file? Right now, this recipe doesn't handle that. It basically needs to use something called data flow analysis to go back and find it. The framework has the ability to do that. I just ran out of time to add this, so sorry, it doesn't work. The last piece of this I also kind of want to mention is inside this visitor. You see here the search result found. Okay, so in addition to all the other stuff I've told you about what an LST can contain, there is this metadata called a marker behind the scenes. That is extra metadata you can attach to LSTs, arbitrary metadata. And the framework has certain ones that it knows about. Search marker is one of these. A search marker is basically saying, cool, I've got something in there. And when you see the search marker, and when you're printing out the source code at the end of this whole process, it'll basically reify those in code with little comments. So you can actually see where in the source code this annotation was, in addition to the list. So I'm going to show what this recipe looks like real quick, hopefully real fast. Then I'll be done. Okay. So going back to the pet clinic. Maybe. Jeez. My brain's fried. Okay. Get rid of that. Last recipe. First of all, we're just going to roll back everything. We don't need it. Maybe. And then you kind of get used to doing this cycle, right? When you're building recipes, you're just not afraid to roll anything back because you're just going to regenerate the thing. You don't really care. So in this case, we're just going to comment that one out, and we're gonna uncomment this one. And hopefully I've done this right. Okay. So this isn't gonna create any source code changes. Well, actually it will, because I've added markers. Okay, you'll see that one of these little things in here is, hey, there's a data table right here. It's in the target folder. So again, this is just kind of standard Maven stuff. I go in the target, I go into rewrite. Oh, I've run this a lot. Okay, this sure. Yeah, that looks right. And sure enough, there it is. Okay. Can we open this? Open in, sure, in Finder. So this is kind of fun. So basically it's telling me, there's my properties. So these are all the properties that are being used in line and values. So I can tell these are coming from the value annotation. And I'm telling, it'll tell me which file they're in, right? The reason I use the markers, right? I got done with this. I'm like, well, that's cool, but wouldn't it be better if I can actually pinpoint exactly where in the file they're referenced? So what I end up doing, I ran out of time, is I use markers to basically spit out, modified source files that actually kind of highlight where these things are. It works for, there are no conditional on properties in here, but it does work. Again, if you were to go back into some of those tests, I'll leave this as an exercise if you really are interested in this stuff. There are tests for the conditional property as well. So you can see here, I'm like, if I have a conditional property like this, then I expect to get conditional property in my data table. But again, you can see it gets a little more complicated down here where I have a name that's a property and a prefix of my, then I expect to see my property. So all these tests are in fact working. And this is one case where we have two properties. Okay, cool. Okay, hopefully that's it. This is pretty technical deep dive into like the rabbit hole that is this framework. The learning curve is steep. If you're going to do, like, if you have to get into this code, it's pretty gnarly. It can be super fun and super gratifying because, again, you can like run a recipe and if it doesn't work, you just roll back and you keep trying until it works. That's kind of like, I just bang my head against it till I figured it out. The community is really helpful doing this, but this is kind of like just kind of pulling back the curtains on what it's actually doing. Those huge migrations where you're like, how did it migrate all the way from 2.x to 3.x? It's just not rocket science. It's not AI. It's just a lot of work that's been boiled into this. And so community keeps adding more and more recipes. There are more and more languages. This, I think in 5 years, this ecosystem is going to be really mature. It's not going to replace SonarQube yet. It's not going to replace your security scanners or Defendabot, but it could in the next couple of years, I think. So that's it.